Hi friends, in this video we see electron devices and circuits question asked in previous year Tneb exam. Right? Let us see the questions. The first question is three identical single-tuned amplifiers are connected in cascade. The 3 dB bandwidth of each amplifier is 100 kHz. What is the overall 3 dB bandwidth? So the overall 3 dB bandwidth in cascade amplifier is given by fh dash is equal to fh into 2 power 1 by n minus 1, where n is the number of stages, fh is the bandwidth of the individual stage. So fh is bandwidth of the individual stage, that is 100 kilohertz. So 100 kz into 2 power 1 by n. N is the how many stage they are telling? 3 stage. So 2 power 1 by 3 minus 1. So if you simplify, what you get is 50 kilohertz. So the answer is option C. Next question. Silicon is not suitable for fabrication of light emitting diode because it has a direct direct band gap semiconductor, right? For silicon, for LED we need indirect band gap, so that is gallium arsenide, indium phosphide and all we need, right? So that is the question, right? Next question is a rectifier which requires minimum amount of filtering is full wave rectifier because it has less ripple, right? So it needs minimum amount of filtering. It has less ripple means what? It has less AC component, right? Next one, cut-in voltage of a silicon diode is, we know it's a direct question, 0.6 volt. For germanium it is 0.3 volt. Next question, bipolar junction satisfies which relation? Beta is equal to alpha by 1 minus alpha. So it's a direct question. If they ask alpha, alpha is equal to beta by 1 plus beta. And next question is, consider the following common type of transistor. The current arrangement of this transistor in the increasing order of input impedance. So FET and BJT they are given, which has less input impedance. BJT has less. Then point contact transistor. Then JFET. MOSFET has the highest impedance, right? So this is the order, right? So option D is a correct answer. Next question, what do you call? What will be the period and frequency of oscillation of an unstable multivibrator for the given data? So first we find period. Period of the unstable multivibrator is given by T is equal to 0.69 R1 C1 plus R2 C2. So they are given R1 value, R2 value, C1 value, C2 value. Substitute all the values, what you get is 0.125 millisecond. And they ask frequency of oscillation also. Frequency of oscillation is given by 1 by T, that is equal to 8 kilohertz. So the option D is a correct answer. Next question. Okay. The transformer utilization factor of a DC power supply may be defined as, it is TUF is equal to PDC divided by PAC rated, right? So rated AC power, DC power divided by AC power, right? So that is what transformer utilization factor. So option B is a straightforward correct answer. Okay, the forward amplification of amplification factor of a transistor corresponds to, transistor is a current control device, so it is simply a current gain of CB amplifier. Okay. Next question, in an ideal differential amplifier shown in the figure, the large value of RE. This question they ask in a regular, most of the exam from a TNEB or TRB. The answer is it decreases common mode gain. So it decreases common mode gain, the value of large value of RE. When RE increases, AC decreases. This means CMRR will increase. That's why they are using like this. So large value of RE decreases common mode gain. Okay. Next question. Consider the following statements regarding the RC phase shift oscillator. The amplifier gain is positive. No. Then the amplifier gain is negative. True, because it is using the amplifier, transistor amplifier, so it will produce 180 degree. The phase shift introduced by the feedback amplifier is 180. So it is introducing 180 degree phase shift means gain won't be positive. And the phase shift introduced by the feedback network is no, it is not 360 degree, it is 180 degree. So option 2 and 3 are correct. Next question, class B amplifier, the maximum power rating is power is equal to Vc squared by 2RL. Direct question, very important. Vcc squared by 2RL. This is not at all a power equation. So from the question itself we can understand. So option A or D should be correct. This 2 won't be. So either A or D. So it is RMS power. So Vcc by 2RL. Vc squared, right? Next, the effect of saturation in a rectifier transformer is it will decrease the output. That is very important, right? Direct question only, right? So DC saturation will decrease the output. Next question, the power dissipation of the transistor equals the collector emitter voltage times into load current, right? So it is also a direct question. Mostly they ask direct question in Tneb exam. So it is equal to load current. Next one, the output impedance of a voltage regulator is very small. Direct question, right? So I think it is repeated, so leave it. Next question, the figure shown here is okay. By seeing the figure, so we see it is diode and RC network, so surely it is a clamper, right? So it is a clamper circuit, right? Okay, clipper will not have C, right? So let us see that. Next question, what do you call, the variation of transconductance of FET is proportional to, we know transconductance sequence of FET is given by GM is equal to 2IDSS divided by VP 1 minus VGS by VP. So GM is directly proportional to IDSS. So it is not this one, it is IDSS, right? Option A is the right answer. Next question. The beta of a transistor reduces if the base width is increased. The beta of a transistor increases if the doping concentration in the base is increased. So beta is a common emitter current gain. Common emitter current gain will increase if the base width is increased is true. Alright. Okay. Next, beta increases if the doping concentration of in the base increases. No, that is false. So 1 is true, 2 is correct, right? So that is very important. Next, it's a direct, mostly direct questions. Avalanche photodiodes are preferred over pin photodiodes in communication system because avalanche photodiodes can handle high power. So option D is a right answer. Okay, the Q point of a voltage divider bias should be, the main point about voltage divider bias is Q point is insensitive to change in current gain. That is an important question. So this question may be asked in TRB also, right? Q point is insensitive to change in current gain. An amplifier is one which has infinite voltage gain, maybe positive feedback. No, it is an oscillator. Uniform frequency response, that may vary. It may have, ideally it has infinite voltage gain. So this is wrong, this is wrong. It responds only to signal at its input, right? So option B is the right answer, right? So next one, yeah, Wien bridge oscillator is given here, R1 R2, right? So okay, this is very simple. Yeah, Wien bridge oscillator has R1 is equal to R2 is equal to 220K, C1 C2 is equal to 250 picofarad. What is the frequency of oscillation? For main bridge oscillator, frequency of oscillation is given by 1 by 2 pi root of R1, R2, C1, C2. R1 is given, R2 is given, C1, C2 is given. So 1 by 2 pi R1, R2 is 220K whole square. K means 10 power 3 into C1, C2, 250 into pico. So 10 power minus 12 square. If you simplify, what you get is 2.89 kilohertz. So option C is the right answer. Next question. The frequency response of a tuned amplifier resembles. So for tuned amplifier, we know the frequency response like this. It is like a band pass filter, right? Because we know band pass filter only has a frequency response like this. F. This is magnitude. So it is a band pass filter. It is also appearing like band pass filter. So tuned amplifier has a frequency response resembling band pass filter. Next, the dynamic resistance of a diode, right? So dynamic resistance of a diode is given by RD, that is equal to del V by del I, change in voltage divided by change in current. So dynamic resistance is nothing but AC current. So it is a, the resistance is nothing but opposition. So it is the opposition to the current flow. So AC opposed, because dynamic means change. That itself you can have a clue. Dynamic means change. AC only will change. Right? Resistance of a diode in forward bias wrong. Resistance of a diode in reverse bias is also wrong. For dynamic, we know change. So change means AC. There is a clue in that, right? Okay. Next, a stable multivibrator has no stable states. That is very easy. Bistable has two stable states. Monostable 1.5. Right? Okay. Fine. Next question is, in class C amplifiers, right, current flow through the active device for less than half cycle. Okay, so that we must know. In class A, it goes full cycle, current flow full cycle. Class B, half cycle, right? In class C, less than half, right? Okay. Next question. H parameter is more commonly used because we know H parameter is easy to calculate. That is the biggest advantage. H parameter don't vary with the frequency. That is not a correct answer. H parameter is an accurate representation, right? So those are all wrong. The main thing we are using, main advantage of H parameter is we can measure it more easily, right? Next one, what do you call? Yeah, amplifier has a gain of 20 without feedback. So gain of 20 without feedback is AV. Let us assume voltage gain 20. If 10% of the output is fed back by means of a negative feedback, so negative feedback, so it is a feedback factor, 10%, right? So beta is feedback factor. It is a negative feedback. What is the overall gain? So overall gain AV dash is equal to AV divided by 1 plus beta AV. Why 1? Because it is a negative feedback. If it is a positive feedback, it is 1 minus. So AV is 20. 1 plus 20 into 10% is 0.1. 2 plus 1, 3. So 6.67. So the overall gain is 6.67. Next question, the magnitude of the negative resistance of a tunnel diode is maximum. We know it is between the peak point and the valid point. Why? We know the tunnel diode characteristics will be like this, right? So we know it is Vp, it is Vb. This is the negative resistance region, right? So here when voltage increases, this is I. When voltage increases, here you see this is V1, let us assume V2. When voltage increases, current is decreasing. So negative resistance. So the negative resistance will be, magnitude of the negative resistance will be maximum in between peak point and the valley point. So option C is the right answer. Next question. Bistable multivibrator can be induced to make an abrupt transition from one state to another state through external excitation, right? So that is very important. In bistable, we apply external triggering, that is external excitation. Okay. Unique feature of CC amplifier, CC is nothing but voltage follower, right? So in voltage follower, whatever the thing happen, output voltage is equal to input voltage. It is an impedance matching device, right? So Ri should be tends to infinity, Ro tends to 0. These are all the characteristics of voltage follower. Let us see, it steps up the impedance level. True, it doesn't increase the signal voltage. It won't, because output voltage is equal to input voltage. It won't increase. Yes, true. It acts as the impedance matching. That is also true. So the answer is all of the above. Okay, next. The breakdown voltage of a Zener diode ranges from, yes, it has a minimum breakdown voltage of 2 volt to 800 volt. So option A is the right answer. Next question. Important application of Smith trigger is, yes, of course, it is used as a squaring circuit, amplitude. It is a comparator. Smith trigger is another name is regenerative comparator. So it is used for comparing. So it will square it. It is acting as a flip-flop. So option D, all of the above. Next one. The cascade amplifier has, what is the cascade amplifier? It is a combination of CE and CB. So common emitter and a common base. Colpates and Hartley oscillator belongs to a general class of oscillation that uses, oscillator uses voltage series. Right, so voltage series feedback. Option A is the right answer. Positive feedback reduces, positive feedback increases the instability. It will produce noise and it will produce distortion. It will reduce the bandwidth. So option D is the correct answer. Half power gain is maximum gain. It is minus 3 dB gain is known as half power gain. So option D. You see here they have put minus. So minus 3 dB. Next, in differential amplifier, the gain is 20,000 CMRR 80 dB. What is the common mode gain? Differential mode gain they have given. So first we must know CMRR in dB they have given. Convert into first number. So 20 log CMRR is equal to 1080. This implies log CMRR 10 is equal to 4. This implies CMRR is equal to anti-log 10 power 4, that is equal to 10,000. CMRR we found 10,000. So what is CMRR equation? CMRR equation is AD by AC is CMRR, that is 10,000, right? What is AD? Differential mode gain is 20,000. So 20,000 is differential mode gain divided by common mode gain. This is 2. So this implies AC is equal to 2. So the answer is option A, 2. Next question. In a common emitter amplifier, the unbypassed emitter resistance provides negative voltage feedback. Very important question. This question they are asking many times. So in C amplifier, the unbypassed resistance provide negative voltage feedback. Voltage shunt feedback. What it will do? You see, whenever we have a shunt, right? Shunt or series, it's talking about input. So Ri, shunt will decrease the input resistance, series will increase the output resistance. Similarly, you see voltage or current or I, Vi, so Ro, V decreases Ro, I increases Ro. So what is happening here? Voltage and feedback decreases input resistance and output resistance. Voltage shunt. So option D is a right answer. Next question. The output of an ideal differential amplifier when the same input signals are applied to the input is, what is differential amplifier? It will amplify the difference between the input signal. When the same inputs are applied, what is the input value? I is equal to 0 because difference is 0. So what will be the output? Output is 0. Right? Next. The feedback factor for a voltage shunt feedback. Right? So voltage shunt feedback factor is IF by VO. Okay, so this we must remember. Right? So feedback factor is output by input. So this is IF by, so it is feedback current, output voltage, right? So voltage shunt, voltage is taken from the output. You see, this is a amplifier. So here voltage is taken as shunt. So voltage, so the output voltage is taken. That here the feedback factor beta, right? So shunt means it is connected in shunt here, right? Voltage is taken, so voltage is output. Shunt means you connect here as a current, so here it should be IF. Feedback current, it is VO. So what is the output here? IF. Input is VO. So beta is equal to IF by VO, right? Current shunt means IF by IO. Clear? Series means VAF, right? So series means VF. So the shunt means, right, I. Series means V. Okay. So voltage we have taken. So that is the voltage shunt means output is voltage. Voltage is taken. Shunt means I. So IF feedback. This is feedback IF by VO. Okay. Next one. The percentage regulation of a rectifier is V no load minus load. Sorry, of a rectifier is V no load minus V load divided by load 100%. Right. So option C is the right answer. Next. The output DC voltage of a full wave rectifier is, these are all direct question. VDC is equal to 2Vm by pi minus IDC RF. So option A. Next question. Diodes are used to clip voltage. That is, diode acts as a clipper. What is the reason? Because the voltage source is under certain bias condition. Right? Diode acts as a voltage source. It is not acting as a current source. Right? So all the other answers are wrong. Diode acts as a voltage source under certain bias condition. That's why it is used to clip the voltages. Fine. Okay. Next. Major part of the current in intrinsic semiconductor is due to conduction band electrons. This is a direct question we know from our semiconductor itself. In saturation region, JFET acts as a parabolic, right? It is a square law device. So it is the curve characteristics are parabolic. Next question. The op-amp series voltage regulator output voltage depends on, so the output voltage of the op-amp series voltage regulator depends on Zener voltage and what you call voltage divider resistor. It depends on both the values. So option A and B both are correct. So this is very important question. They are asking it in sometimes. So please remember this question. Right? Okay. And next question is, let us see. So first I write this. Output voltage depends on VO is equal to VZ 1 plus R1 by R2. So this is what voltage divider resistor. This is what Zener voltage. So in op-amp series voltage regulator, output voltage depends on both. Right. Next, the diode, which is often used for voltage regulation in electronic circuit, is Well-known question, Zener diode. Gallium arsenide, it is LED is used to emit IR radiation. This question they are asking many times, so please remember this. Right? The main use of emitter follower is it is used for what you call impedance matching. Right? Okay. Next one. For an ideal noise-free transistor, the noise factor should be 0 dB. Right? Not 1 dB. Please, it is 0 dB. Noise factor should be 1. Right? In dB, it is 0 dB. The negative feedback amplifier, the negative feedback is an amplifier. What will happen? It will increase the bandwidth. How? It will lower its lower dB frequency, increases its upper dB frequency. So let us assume this is lower, this is upper. What your negative feedback will do? This one, shift this F1 to this side, shift this F2 to this side. So this will become F1 dash, this will become F2 dash. So bandwidth will increase. So negative feedback increase the bandwidth by using these two techniques. So all the three are correct. So option D is the right answer. Next question, what do you call? Okay. Sorry, 15. Okay. The DC line of a transistor is curved line. No, it is a straight line. It gives relationship between IC and IB. No, it gives relationship between VCE and ICE. ICQ, VCEQ. Doesn't contain Q point. No, it contains Q point. So it is also wrong answer. So it will be like this, right? What we have seen. So here only we have Q point. It is VCE. ICE. It is a negative resistance line. So it is negative slope. So option A is the right answer. Next question. Leakage energy of a PN diode is caused by heat energy. Right? When diode heat is producing, there is no chemical energy. The leakage is not due to majority carrier. Barrier potential won't cause leakage. Okay. Next question. The switching time of LED is of the order of nanosecond, right? So not in microsecond. So LED switching time is in the order of nanosecond. So 1 nanosecond. Next one, avalanche breakdown is due to impact ionization, right? So option C is the right answer. You see the next question, gallium arsenide. Again they are asking gallium, not comma. Gallium arsenide LED emits in the IR region. So this is a repeated question. Okay. Next one, which of the following methods used for biasing BJT in integrated circuit? Right? So this one is voltage divider bias, very important, which is independent of the transistor beta, voltage divider biasing. Right? If two stages of amplifier has a decibel gain of one is 60 dB and another one is 30 dB, what is the overall gain? If it is in gain, add two gains, so 60 plus 30, 90 dB. If it is not in gain, simply 60 30 means you have to multiply 60 into 30, then we have to take 20 log, so that will give the gain. So since it is in gain, you just add, so it is 90 dB, right? Okay. Next one, in a common emitter amplifier, the unbypassed emitter provides, right? So this question already they have asked current series feedback. So it is a very important question. They are asking many times, right? So unbypassed emitter resistor provides current series feedback. The depletion region of a semiconductor diode is due to migration of charge carrier. Okay. Next question is a 741 op-amp has an open loop gain of AV is equal to 2 lakhs and input offset voltage is VIO is 2 millivolt. What is output voltage? So output voltage VO is equal to VIOS into AV. So 2 millivolt is 2 into 10 power minus 3. This is 2 into 10 power 5. So 2 into 4, 2 into 2, 4, 4 into 10 power to 400. But here they don't give what is the polarity of the input offset voltage. So what you have to do is output voltage may be plus or minus 400 volt. I don't think it is plus 2 millivolt. They will give the polarity positive or negative. Okay. So the answer is 400 millivolt. Plus or minus. Next one, you see this question also they ask regularly the relation between alpha and b. Alpha is equal to beta is equal to alpha by 1 minus alpha. Is there anywhere? Yes. Okay. Alpha is equal to beta by 1 plus beta. This question they are asking regularly. The maximum efficiency of a class B push-pull amplifier cannot exceed 78.5%. Next one. In a two-stage amplifier, two stages has voltage gain of 20 and 60 dB. Then overall, just now only I told if it is in dB, just add the gain. So 20 plus 40 is 60 dB. If it is in a number, you have to multiply and take 20 log. Right? Next question is a transistor used as a switch is operated in cutoff and saturation. Transistor as amplifier, it is used in active region. For switch, it will operate in cutoff and saturation region. Okay, you see the relationship between beta in terms of alpha. Beta is equal to alpha by 1 plus alpha. So this is wrong. This is right answer. Next question. The frequency of oscillation of a RC phase shift oscillator is, this question also they are asking regularly, 1 by 2 pi RC root 6. Option B. Now, the next question, for the non-inverting amplifier shown in the figure, find the output voltage. For non-inverting amplifier, VO is equal to VI into 1 plus RF by RI. VI is input voltage. Right, for the input of they have given 1 volt, 1 plus RF is feedback resistor. This is what RF, so that is 10K. RI is input resistor, RI is input, that is 1K. So what will happen? That is equal to 11. 10 by 1 is 10, 10 plus 1 11, so it is 11 volt. So option B, C is the right answer. Next question. Which of the amplifier is the highest out of all the power amplifier? Class C has the highest efficiency. Next question. In a common emitter configuration, calculate emitter current IE. IE we have to calculate. It is common emitter and for which beta is equal to 50. IB is equal to 20 microamps. So for common emitter amplifier, beta is equal to IC by IB. This implies beta is 50, that is equal to IC divided by 20 microamps. That is equal to IC. IC is equal to 50 into 20 into 10 power minus 6. That is equal to 1 milliampere. Fine. So what they ask is IE. IE is equal to IC plus IB. IC equal to 1 milliampere. IB is 20 microampere. That is equal to 1.002 milliampere. Right. So here there is no such answer. So this is more or less correct answer. Okay. Next. Avalanche breakdown results due to disrupting the bonds. That is a direct question, no problem. Right? So from breakdown, they are asking one question. Next question, the most desirable feature of transformer coupling is impedance matching. That is very, transformer coupling's main use is impedance matching. Next one, the input, if the AC input of a rectifier has an RMS voltage of RMS voltage, Vrms equal to 400 divided by root 2. What is peak inverse? Peak inverse equal to Vmax for of a rectifier. Vmax is nothing but Vrms into root 2 Vmax as per the VRMS as per the problem is 400 divided by root 2 into root 2, that is equal to 400. That's what peak inverse voltage. So the answer is 400 volt. Next one, the AC drain resistance of a JFET. Since it is a resistance, it must be a ratio of V by I. It is I by V, it is wrong. It is I by V, it is wrong. AC drain resistance is VDS by ID. So option A is the right answer. Right? Next question, for a full wave rectifier, match the following. For full wave rectifier, IDC is equal to 2Im by pi. So it is A. Ripple factor is 0.41482. So the answer is this is B. Efficiency 81%. C, and IRMS equal to Imax by root 2. So option B is the right answer, right? Okay. IDC is 2Im by pi. And the last question is, which of the following is not an advantage of Darlington pair? Darlington pair, we can easily form two adjacent transistors. Darlington pair, as the name itself is telling, we have two adjacent transistor in Darlington pair. That is possible to fabricate in IC, and it provides very high gain value. This is very important question they are asking many times, and it has impedance transformation capabilities. So all are right. This is the only wrong answer. So it is the correct answer here. So it has low impedance transformation capability. No, Darlington pair has high impedance transformation capability. Right. So that's all about this session. I hope you understand everything very clearly. If you have any doubt, please ask me in comment section. I will clarify. Thank you.